Hi guys, so coming back to the first tutorial about the design pattern, which we will be learning the strategy design pattern. So say if we are making an RPG game, and now we have a base class already, which is a player. But every player that can choose freely among the races. So they can choose like they want to be a human, they want to be an angel, or they want to be a devil. So this abstract class, it implements the run method, which can be used by everyone. So regardless what character you are choosing, what race you are choosing, you'll still be able to run. And they will have some HP and level available as well. And this display abstract method is going to be implemented by the particular subclass. So they can choose what kind of form they want to be displayed. So there is it for the base class as well as the subclasses we have currently. So the reason why we are doing the inheritance in this way is because, let's say if we are not using the inheritance, everyone will be just having their own method, just having their own HP level and so on. In that case, we will not able to group them, for example, in an array. If you want to do a multiplayer, right, we need to have a players equals a new player, and putting in the human, angel, and devil all together as a group of players. If we are not using the same parent class, we are not able to achieve that. So right now, I can simply use the concept of polymorphism to generate a new human, for example, as a player. So this is called the concept of polymorphism. Now, I can group them together and angel, human, this is devil, and use a for loop. Yeah, I can do something like this. So right now, although I understand already, but I haven't implemented the display method yet. So I need to print the line and say that I'm human. And here will be I am angel. Here will be I'm devil. So this is the fundamental design of the players, which we haven't implemented strategy pattern yet. So now the problem comes here. Say if suddenly one day we are required to add extra features, but not for every player. So for example, I want to add wings for the angel. In order to add the wings for the angel, now first we can think of how about we make something like an interface. So let's say if we have an interface like flyable, so this will indicate that the particular player can fly, which I have an abstract method fly. So this is the flyable, and let's say if I only want the angel to be able to fly, I will just implement the flyable, right? Then here I will override the method of the fly with my own implementation. I am flying. Then okay, once I have done that, I will be able to fly, I think, new angel, then angel dot fly. So let's say if this works or not. Try to run it. Now, I am flying, so it means that it works. But we need to implement the flyable, right? So for example, I have another new feature. Let's say for example, what features you want to have? Teleport, let's say. And this is also an interface teleport, which every time if I want to be able to teleport, I need to implement it. So now you can see a little bit of the redundancy here. We are using the interface to keep track of what methods we have, what things we can do with the class. But every time if I want to implement a new features, well, I need to write in every subclasses. So let's say if the devil needs to do the same thing, it needs to implement these two things as well. And I need to repeat the implementation here. Well, it is cumbersome. Very, very cumbersome, right? In writing codes, we always want to avoid such redundancy happenings. So now, say if the devil also I want to be able to fly as well as teleport. So I will move the interface implementation to this subclass as well. So now we got a redundancy here. How can we solve it? Again, we are still not yet using the strategy pattern. So the normal way we can solve it. So for example, if let's say, if I don't want, how if I don't want to implement the feature inside here, the subclass, I want it to be in the parent class. I will just implement this flyable and teleport. Actually, it's teleportable. So, and I will implement the both classes here, so I can avoid redundancy, right? Apparently, I can avoid that. So these two I don't have to implement already because the parent class already implement. Now we are reducing a lot of codes, but here comes the problem. If you are implemented in this way, it means that every player can fly. So including the human can fly, which we are not supposed to, right? Only angel and devil are supposed to fly. So now even human is able to fly already. So this is not going to be working. But we can still make it work by using a very, very hacky way, I can say. So let's say fly and teleport is not supposed to be happening in human, right? So I will just override it and do nothing. So this is how a human which was supposed to fly, then suddenly they cannot fly because I override it and I didn't do any implementation for the fly and teleport. So if you are doubting what am I doing, I can actually show you by using here fly. Let's try to run it. Now you can see this is human. Human can never fly, but angel and devil can fly. So this is a hacky way of doing it. Is this feasible? Well, this can be done, but again, as I mentioned, this will cause a lot of troubles and nightmares if you want to maintain the curse. And this is never a good practice of overriding and do nothing. Yeah. So now we already know that using the interface is not a feasible way. So what else we can do? Now here comes the play of the strategy pattern. So in strategy pattern, there are several principles that we need to know. The first thing is the strategy pattern is to group the similar things, group the same thing, and separate the difference. So we are grouping all these like the attributes and methods that everyone can do together. So we try our best to put everything in the parent class and separate the difference only in the subclass. So we are already doing it even though we are not implementing the strategy pattern yet. And the second thing is instead of using the inheritance, or we actually favors using composition. So what is composition? I can show you right here. So flyable. So this flyable is still applicable. So let's say now we are implementing the strategy design pattern already. So no wing implements flyable and it will fly. But I cannot fly. So this player, there are no more implementing the interfaces for flyable and teleport. So we have a class knowing which implements the flyable and overrides the fly method with I cannot fly. So composition plays here. So let's say if you have flyable, and inside the constructor, or let's say if I don't want the constructor also can, new no wing. So this is the default wing, which is no wing, that indicate that the player cannot fly. So flyable is a behavior, I can say. So this is a way of composition, which as compared to inheritance, which we extends the, let's say we extend the flyable, this is the inheritance, which it is already bound with the particular class, and I have to implement it on before even I compile the codes, right? So let's say if I want the player to be able to fly, I need to extend the flyable or implement the flyable, and I need to do the method implementation straight away. So that gives me a little bit inflexibility that I cannot change it in runtime. So by using the composition method, we are declaring the object which is in charge of the particular behavior. So this is a class for behavior. So usually we create a class for the sake of like storing some attributes as well as the methods, right? So now we are using the class for declaring a particular behavior, for example, fly. So by doing this, we are actually providing a flexibility for the user to be able to change the wing at runtime. So let's say if I am exposing the set flyable with flyable, then this dot flyable equals to flyable. So this comes the magic. So let's implement another class, that is the butterfly wing. So it implements a fly wing. I am flying with butterfly wing. So this butterfly wing will be, okay, these two things I don't need already. So right now we have the teleport, so we don't need. We are only focusing on the wings. So we have the flyable, which is in charge of flying, and we are setting to flyable. And here we have a method called fly, and we are not implementing directly in the method itself. In fact, we are calling the flyable. So flyable is an interface which I have been emphasizing that we should use the polymorphism to provide us more flexibility, right? We are depending on the abstraction, not the concrete class. So I'll be explaining this more in the future. So right now, just keep in mind that every time, if it is possible, if it is appropriate, we will try our best not to create an instance upon a concrete implementation. In fact, we create an instance upon an abstraction, for example, abstract class, for example, interface. Coming back to the problem here. Now, as you can see, the way I implement this is already the strategy pattern, yeah? So I'm using a composition to create an instance for behavior. So this flyable is in charge of the behavior, which the default behavior is no wing, which indicating that I cannot fly. Now, as we can see in the angel, for example, if I want the angel to be able to fly, I can actually do something like this. Inside the constructor, I will call the super constructor first. Then after this, I will this set flyable equals to new butterfly wing. So now we are setting a new butterfly wing to the flyable. Let's try to see what will happen, yeah? Java main. Now, as you can see, for human, maybe I will just Nearby. Okay, so this is for human. Human I cannot fly, but for the angel we already apply with the butterfly wing. What a magic! And for the devil, still I cannot fly. But let's say this is the first good thing about the strategy pattern is that we can change in runtime. So for example, if I want the, let's say this is devil, right? Player 2 is devil. Then I want it to be able to fly suddenly. Yeah. So I can say set flyable equals to new. Let's say I want to have a devil wing. Devil wing. And now we have a new devil wing incoming. So we can just equip the player with the wing and tell him to fly again. Oh no. Players. As you can see, initially the devil cannot fly, but after I equip with the devil wing, I'm able to fly now. So this is the magic for the strategy pattern. Now, let's try to revise again what we have done. Initially, we used the interface itself to plug with the parent class. And that will provide us a lot confusion, especially for the human player, which cannot fly at all. So if I'm a human and I don't want to fly, in that case I need to implement an empty implementation for the fly as well as the teleport method, right? So that's not the case where we want to. So after that, we try to use a composition. Here comes the plan of the strategy pattern. So we use a composition to set up an object for us just for flying. So let's say if in the future, if I want to add a new feature like I want to be able to teleport, I want to be able to attack with some spatial abilities. In that case, also I can expose several other objects. So using the strategy pattern is very convenient that we can set the behavior in runtime. So let's say if initially the player cannot fly, but after I equip with some special weapons, for example, or equipments, I will be able to fly. Like with some rocket jack, I'm able to fly. So I will be able to set in runtime, like set flyable new rocket jet. Then the player will be able to fly already. So this is the magic of strategy pattern, which is very, very useful. So we are providing the spaces for the subclasses to set the behavior. If not, I will be using the default behavior of the parent class. Well, I hope you can get an idea of what I'm trying to explain about the benefits of the strategy pattern, and I hope that you are able to apply it somewhere when you're writing your codes. Yeah, so try to refresh your mindset that classes are not only for storing objects. They can be used to abstract the methods to represent several behavior as well. Well, what else I miss? Well, I think that's it. Remember, to use the composition prefers the composition over inheritance. This is the first rule. Then the second rule, group the same, separate the difference. So that's it for this video. Yeah. See you again. Bye.